Good morning everyone. My name is Karthik Suresh. I am here to discuss about power generation using speed breakers. Introduction. A large amount of energy is wasted by the vehicles on the speed breakers through friction every time it passes over it. Energy can be produced by using the vehicle weight and speed. So here we propose a smart speed breaker that generates power. We design a smart speed breaker that can passes vehicles coming from the both sides and yet generate energy from it. Basic principles. Simple energy conversion from mechanical to electrical. To generate electricity using vehicle kinetic energy as input. We can develop electricity from speed breakers. They are using three different mechanisms. നമ്മളിതിൽ യൂസ് ചെയ്യുന്ന മെയിൻ പ്രിൻസിപ്പിൾ മെക്കാനിക്കൽ എനർജീനെ ഇലക്ട്രിക്കൽ എനർജി ആയിട്ട് കൺവേർട്ട് ചെയ്യുന്നു. നമ്മൾ വെഹിക്കിളിൽ നിന്നുണ്ടാകുന്ന കൈനറ്റിക് എനർജീനെ ഇൻപുട്ടാക്കി വെച്ച് നമ്മൾ സ്പീഡ് ബ്രേക്കേഴ്സ് വഴി നമ്മൾ ഇലക്ട്രിസിറ്റി ഉൽപ്പാദിപ്പിക്കുന്നു. അങ്ങനെയുള്ള 3 മെക്കാനിസമാണ് നമ്മളിവിടെ പറയാൻ പോകുന്നത്. റോളർ മെക്കാനിസം, റാക്ക് പിനിയൻ മെക്കാനിസം, ക്രാങ്ക് ഷാഫ്റ്റ് മെക്കാനിസം. റോളർ മെക്കാനിസം. This is roller mechanism figure. Okay. A roller blind mechanism for winding and unwinding a rollable blind. The mechanism compressing a support element, a drive sprocket with is rotable mounted on the support element for transmitting rotational movement to the blind supporting member, and a manually movable elongate flexible drive element which includes a plurality of interlinked tooth engaging element. The drive sprocket including a plurality of flexible teeth engageable with the tooth engaging element of the flexible drive element. A roller blind mechanism as claimed in claim 1, wherein radial extent of teeth of the drive sprocket is equal to the greater than a maximum dimension of the tooth engaging element of the flexible drive element. A roller blind mechanism as claimed in claim 2, wherein the radial extent is equal to or greater than twice the maximum dimension of the tooth engaging elements of the flexible drive element. A roller blind mechanism as claimed in claim 1, wherein the teeth of the drive sprocket flexible circumferential direction of the sprocket. Next, rack and pinion mechanism. This is the figure of rack and pinion. Okay. Rack and pinion gears normally change rotary motion into linear motion, but sometimes we use them to change linear motion into rotary motion. റാക്ക് ആൻഡ് പിനിയനെ നമ്മൾ റോട്ടർ മോഷനിലെ ലീനിയർ മോഷൻ ആയിട്ടാണ് നമ്മൾ കൺവേർട്ട് ചെയ്യണത്. ബട്ട് സംടൈംസ് ഇതിനെ ലീനിയർ മോഷനിൽ നിന്ന് നമ്മൾ റോട്ടർ മോഷനായിട്ട് നമ്മൾ എടുക്കാറുണ്ട്. ഓക്കെ. We use them to sliding doors moved by an electric motor. The rack is attached to the door and the pinion is attached to the motor. The motor moves the pinion, which moves the rack and door moves. Then crankshaft mechanism. ഇതാണ് ക്രാങ്ക്ഷാഫ്റ്റ് മെക്കാനിസത്തിൻ്റെ ഫിഗർ. ഈ ഫിഗർ കാണുമ്പോൾ തന്നെ നമുക്ക് ചെറിയൊരു ഐഡിയ കിട്ടും. നമ്മുടെ സിമ്പിളായിട്ട് പറയുകയാണെങ്കിൽ നമ്മുടെ വണ്ടിയുടെ എഞ്ചിനിൽ തന്നെയുള്ള അപ്പ് ആൻഡ് ഡൗൺ മോഷനെ നമ്മൾ റോട്ടറി മോഷനായിട്ട് കൺവേർട്ട് ചെയ്യണേ നമ്മുടെ ക്രാങ്ക്ഷാഫ്റ്റ് മെക്കാനിസം യൂസ് ചെയ്താണ്. ഓക്കെ. The crankshaft is a mechanism that transforms rotary movement into linear movement or vice versa. For example, the motion of the piston in the engine or a car is linear, but the motion of the wheels has to be rotary. So engineers put a crankshaft between the engine and the transmission into wheels. The pistons of the engine moves the crankshaft and the movement become rotary. Then the rotary movement goes past the clutch and then the motory movements goes past the clutch and the gearbox all the way to the wheels. Then working principle. While moving the vehicle possesses some kinetic energy and it is being wasted, the kinetic energy can be utilized to produce power by using a special arrangement called power hump. It is an electromagnetic unit. It is utilize both mechanical technologies and electrical techniques for the power generation and its storage. Power hump is a dome-like device likely to be speed breaker. Whenever the vehicle is allowed to pass over the dome, it gets pressed downwards, then the spring and attached to the dome are compressed and the rack which is attached to the bottom of the dome moves downwards in reciprocating motion. Since the rack has teeth connected to gears, there exists conversion of reciprocating motion to the motion of rack into rotary motion of gears, but the two gears rotate in opposite direction. A flywheel is mounted on the shaft whose function is to regulate the fluctuation in the energy and to make the energy uniform, so that the shaft will rotate with certain RPM. These shafts are connected through the belt drive to the dynamos, which converts the mechanical energy into electrical energy. The conversion will be proportional to traffic density. Whenever an armature rotates between the magnetic field of south and north pole, an EMF is induced in it. So, for including the EMF, armature coil has to rotate. For rotating this armature, it is connected to long shaft, but rotating same EMF is induced for the rotating kinetic energy of moving vehicle is utilized. The power is generated in the both direction. To convert this power into one way, a special component is used called Zener diode for continuous supply. All this mechanism can be housed under the dome, like speed breaker, which is called hump. The electrical output can be improved by arranging these power hubs in series. This generated power can be amplified and stored by using different electrical devices. Construction details. The various machine elements used in the construction of power humps are rack, spur gear, flywheel, bearing, shaft, springs, electrodynamo. ഇന്ന് നമ്മൾ നോക്കാൻ പോകുന്നത് പവർ ഹമ്പിന് വേണ്ടിയുള്ള കൺസ്ട്രക്ഷൻ ഡീറ്റെയിൽസ് എന്തൊക്കെയാണെന്നുള്ളത് നമ്മളിന്ന് നോക്കാൻ പോകുന്നത്. അതിന് വേണ്ടത് റാക്ക്, സ്പർ ഗിയർ, ഫ്ലൈവീൽ, ബിയറിംഗ്, ഷാഫ്റ്റ്, സ്പ്രിങ്സ്, electrodynamo. A dome is mounted on 4 springs and in the bottom. A rack is clamped. The rack consists contact teeth on the both of the face. It is connected to two gear wheels to rotate the gear wheels only in one direction. We have inserted a free wheel in each gear. The free wheel and the gear assembly are mounted centrally. The flywheel is also mounted on the same shaft and the shaft is simply supported on the both ends by means of ball bearing. Now a dynamo is connected to each shaft by belt drive. The output terminal of the dynamo is connected into an electric storing device. The total assembly is arranged in concrete pit. Rack. Its primary function is to convert translatory motion into rotary motion. It must have higher strength, rigidity and resistance to shock, load and less wear and tear. Spur gear. It is a positive power transmission device with definite velocity ratio. Involute teeth profile is preferred for adjusting some linear misalignment. It should have high wear and tear, shock absorbing capacity. Flywheel. The primary function of flywheel is to act as an energy accumulator. It reduces the fluctuation in speed. It absorbs the energy when demand is less and release the same when it is required. Shafts. It is a rotating element which is used to transmit power from one place to another place. It supports the rotating elements like gears and flywheels. It must have high torsional rigidity and lateral rigidity. Springs. It is defined as an elastic body whose function is to distort when loaded and to recover its original shape when the load is removed. It absorbs or controls energy neither due to shocks or due to vibrations. Bearings. It is a machine element which supports another machinery. It permits relative motion between the contacting surface while carrying the loads. They reduce the friction and transmit the motion effectively. Electric dynamo. It is a device which converts mechanical energy into electrical energy. It converts based on Faraday's law of electromagnetic induction. First law: whenever a conductor cuts across magnetic lines of flux, an EMF is induced in it. Second law: the magnitude of induced EMF is equal to the rate of change of flux. Next, electricity generation of rack and pinion mechanism. ഇതാണ് നമ്മുടെ സ്പീഡ് ബ്രേക്കറിൻ്റെ പ്രാക്ടിക്കൽ ഫിഗർ എന്ന് പറഞ്ഞാൽ. സ്പീഡ് ബ്രേക്കറിൻ്റെ താഴത്തുനിന്ന് ഒരു കണക്ടർ റോഡ് വെച്ചിട്ട് ഡിസ്കിലോട്ട് വെച്ച് ആ ഡിസ്കിൽ നിന്ന് മോട്ടോർ വഴി ഇലക്ട്രിക്കൽ സ്റ്റോറേജ് യൂണിറ്റിലേക്ക് കൊടുത്തിട്ടുണ്ട്. This mechanism is the third mechanism. It is the crankshaft mechanism. Whenever the vehicle going on the speed breaker goes downwards, so the potential energy is converted into kinetic energy. Here we are used a crankshaft mechanism for the development of this small amount of electricity. The electricity saves on the battery storage unit. The crankshaft mechanism is regained its previous position, vice versa. നമ്മൾ വെഹിക്കിൾ പവർ ബ്രേക്കറിന് മുകളിലേക്ക് വരുമ്പോഴത്തേക്കും പൊട്ടൻഷ്യൽ എനർജീനെ കൈനറ്റിക് എനർജി ആയിട്ട് മാറ്റുന്നു. മോട്ടറിലുള്ള മെക്കാനിക്കൽ എനർജീനെ ഇലക്ട്രിക് എനർജി ആയിട്ട് കൺവേർട്ട് ചെയ്യുന്നു. എന്നിട്ട് ഇലക്ട്രിക്കൽ സ്റ്റോറേജ് യൂണിറ്റ് പോയിട്ട് സ്റ്റോറായിട്ട് നിൽക്കുന്നു. ഓക്കെ. അഡ്വാൻറ്റേജസ്: low budget electric production, less floor area, no obstruction to traffic, easy maintenance, suitable at parking of multiplex, mall, toll booth, signals, etc. Uses: charging batteries and using them to light up the streets, etc. Disadvantages: selecting suitable generator, selection of springs, achieving proper balance of speed and torque. It gives low electric output. Conclusion: as day by day power consumption increases but electric crises occur, so the minor needs of electricity such as street light and traffic signals can be generated from speed breakers. Instead of wasting kinetic energy of vehicles at speed breakers, the minor needs can be met by converting kinetic energy to electrical energy.